Well, thanks again for joining tonight. We've got Levi Bruce and Stew Goumans from Ekahau. They're going to be covering some Wi-Fi concepts in general, and then we're going to get a really nice demo of some of the tools that they have and everything. I'll let them introduce the topic a little more thoroughly and introduce themselves a little more thoroughly. So I'm going to turn this over to you, Mr. Bruce. Please take it away.
Perfect. Thanks, Jason, and thanks for having us on. Stu, are you ready to roll? You have the presentation?
I think so.
Perfect. We can go ahead and jump into that. While
Yeah,
Stu's pulling that up.
I'll pull that up in just a second.
Perfect. I'll just go ahead and introduce ourselves. So my name is Levi Bruce. I'm a channel account manager here at Ekahau. I came over from Cisco 4 months or so ago now. And Stu is one of our wireless experts, our community outreach director, spends a lot of time in the field with engineers such as yourselves, kind of understanding your needs and learning how we can improve our product and go to market. And also he spends quite a bit of time with our manufacturing partners as well, understanding how best to integrate with their dashboards and things. Go ahead and jump a couple slides, Stu.
Ah, yes, thank you. All right, there we go.
Yeah. So we did our contact information's here. We'll make sure you guys have all that if you have any follow-on questions or things you want to discuss deeper. But things that we want to talk about, what's new in Wi-Fi. We're going to kind of start with 6G and how that's really actually coming to market now. We want to talk about streamlining workflows, how Ekahau integrates with AP dashboards for smooth and efficient network management. We definitely want to talk about how to accurately design network. That's a big role that we play, optimal AP placement. We want to talk about real-time monitoring. So everyone knows us from the kind of front-end survey, but leveraging Ekahau more on a real-time and troubleshooting and optimization path. And then we're going to show off some of the cutting edge, latest and greatest that we're coming to market with recently or soon in the future. Go ahead, Stu.
All right.
So Ekahau as a whole, you may have heard of Ekahau, you may have heard of Ookla. You may not know that Ekahau is part of Ookla. They may be using some of Ookla's other properties like speed test or down detector or route metrics. Together, we're kind of really building out this whole connectivity platform, and Ekahau is the RF environment piece of that puzzle. Go ahead, one more, Stu. So I just alluded to it quickly, but a lot of people think of us on the front end of the solution, the wireless survey of an environment, the design of that environment, and doing some predictive design with maybe comparing a couple different APs or comparing what's in the environment today to what we want to put in the environment. But there's kind of that day two optimization that we have a lot of times that if something changes in the environment, maybe you add more. Yes, please feel free to ask questions in the chat. Well, I'll shout them out and interrupt Stu once he gets rolling and bring them up as they're topical. But yes, think about us, not just on the front end, but on the optimization side as we kind of work hand in hand, day in day on our wireless networks. And then also from a security standpoint, wireless security is a very important topic. Security in general is a very important topic. So a couple other places where we play, but I'm going to go ahead and stop talking now. I'm a sales guy. I'm going to hand it over to Stu, the engineer, to dig into the stuff that you guys are here for.
Oh, excellent. Thanks a lot, Levi. And hopefully everything can hear me there. I cannot see the chat screen for some unknown reason, but I'm sure you guys can see that in there. So
yeah, I'll shout them out for you, Stu.
Yeah, it was showing, and it's hiding behind another window, I'm sure, somewhere on my screen. But we'll go ahead. Okay, so where are we at? Okay, hang on. You think, okay. So one of the kind of things I wanted to talk about today, and I think that did I have oh, there it is. Is kind of, let's talk about kind of a 6 gigahertz for a moment here, and that is literally the kind of the big thing that's happening in the market today, right? Is everyone's talking about 6 gigahertz. Where does that Wi-Fi 6 E come into play? What do I need to know about it? And of course, why should I upgrade? What are the things that I need to do? And what parts of that network do I need to kind of make sure that are ready for me, right? So one of the things that 6 gigahertz brings obviously is the additional spectrum, right? No, that's adding a whole new whack of channels and space for that frequency space for us to use to have more higher density access points. When we get into 6 gigahertz, it's not somewhat like the 5 gigahertz range realm is that you can. It is a 6 gigahertz is not as far as 5 gigahertz, and it's kind of breadth of reaching out to clients, so to speak, right? It's actually now we can have more denser spaces and have better connectivity and be able to kind of improve that performance, right? Now, when we talk about performance, that's like, faster speeds and, lower latency, which is really cool. And then we want to get into kind of increased security. So we'll talk a little bit more about what that means, about why we went into Wi-Fi 6 with 6 gigahertz in the first place. Is that, well, if we're going to do this, we're going to do it right the first time. We're going to make sure we're going to talk about that. Increasing that security with our mandatory WPA3 and managed frame protection. And that's really, really important. It's going to be a big change and an uplift to a lot of devices out there. And we're now future-proofing our network. So let's take a look at that, what that means from a, Stu, what do you mean by Wi-Fi 6E and 6? What does that all mean, right? Well, if you look back at kind of the chart here is that we started this journey back in 97, and this is where the old, there was some old 3Com and USR, there was some old USR stuff that was out there in legacy wireless in the beginning that had a bunch of things that were just on the cusp of, okay, let's get this started, right? And they were fairly kind of like, yeah, it'll work, but not really. And you had companies like Aeronet come along that were, prior to what Cisco is today, from a wireless perspective, they had their wireless devices on access points, and they were working out pretty well. And then, of course, we had the clients, right? So we had clients that had these really kind of cheesy radios, and they kind of worked, but it was kind of the wild west days, and that kind of went along almost, I would say, wild west days brought us right into kind of the Series 4 or the Wi-Fi 4 days, right? Which is where you get into 2009 when we started using Wi-Fi. 5 gigahertz was coming to play. It was, well, you could use it on phones and whatnot, but we really started coming of age in around 09, and that was where, hey, we need to start thinking about planning. Corporations are using it. It's not just a nice to have at home. And then now we started to get into kind of the AC type portion of it. We started getting faster speeds, right? And then, of course, Wi-Fi 6 comes along, right? Back in 2019, you think, oh, wow, this takes a long time. But there was a little bit of a hiccup. Might have had to do with some kind of a pandemic of some sort, why there was a little bit of a slowdown in getting that to market. But it did come out, and it came ratified. And a lot of devices were already Wi-Fi 6 ready. The big confusion here, I think, for a lot of folks is not 6 gigahertz. No, it isn't. It was more of a term that they had to use to put in there and for the 5 gigahertz range. But nevertheless, it changed beyond that. It went to 6E, which became 6 gigahertz. And so now that is now where you're living today. We're having a lot of devices now. A lot of all the notebooks that are probably sold today are going to have 6 gigahertz notebook wireless cards. And your phones are most likely 6. Now, of course, with any change, we're going to have 7. 7's the new kid on the block, right? That's even better. More needs and speeds, right? Feeds, needs, and speeds. And you're like, well, 7? What's this all about? Is that 7 gigahertz? No, it's only 6 gigahertz. That's always been the kind of oh, wow, this should be 7 gigahertz, right? Well, yeah, I guess it would be, but it's not. This is actually the next protocol called 802.11be. So this is where we got Wi-Fi 7, and that's 2, 4, 5, and 6 gigahertz. Now, from a 6 gigahertz perspective, what we're doing here on 6 gigahertz is that, or for a Wi-Fi 7 perspective, is that we're going into a different realm of, we're talking about better speeds and connectivity for low latency, but we're also going to talk about some other little features that come along with it. Just to give you an idea of that channel and space that I was mentioning earlier, we're talking about 2.4 where we had, available channels to use 1, 6, and 11, or 1, 4, 8, and 11, or 1, 7, and 13. And of course, those depend on the region that you're in. So the 13 channel, that's going to be like our folks in Asia, like in Japan mostly, they're going to be using that. That's where they got away with using those channels, and they worked well. But we've always been accustomed to 1, 6, and 11. And of course, our 5 gigahertz range, we only had about 25 non-overlapping channels. Now, remember, That wasn't the case for many regions around the world. They may not be able to use all of the 1 through Uni 3. And that drove that conversation. It's like, well, if we can't get all the regulatory change there, can we do it in 6? And the answer was yes, and we could. Citing getting away from a few military bands and weather bands that were still in use today on 6 gigahertz. But now, what's really cool is that the US and the EU have kind of that almost the full clean spectrum, and there's other countries around the world that are have opened up the floodgates on using the entire spectrum all the way from the they go from Uni 4 up to Uni 7. So those are some really cool things that 6 gigahertz brings us today. Now, one of the things we said, why should we have 6 gigahertz? Well, it's cleaner, yeah, because if you remember back in the old days, we had 2.4 microwave oven, 2.4 gigahertz microwave ovens, and we still have this today, right? This is usually caused by older microwaves that have usually probably a broken seal, and you're going to see that a lot of interference. And you may not know why it has a broken seal. It's the door is just overused and it's old, and it tends to leak out some radio frequency on occasion when you're boiling some water or you're cooking your lunch, right? And that does affect certain channels, and it could go from range from 8 all the way up to 13, right, or 12. So just be aware of that. There's still things that are in there if you're still planning to use 2.4. And I'll tell you why this is important a little bit later as well for 6 gigahertz. And you got your headsets, you get your motion sensor game controllers, and you even have even refrigerators and compressors that also come into play as well. So it's always important to still be looking at the spectrum. There are going to be interferers in 6 gigahertz, and in fact, I've seen some already, which are actually kind of cool. Now, 6 gigahertz, what does that mean? Well, there's no legacy devices, right? If they're only doing 2, 4, and 5, well, obviously, well, it's not going to use 6, right? So you're going to have to, and if you're going to be working with a 6 gigahertz networks and all the fun things that it has, then you most likely want to make sure that you're using a newer device, because those devices may not be able to handle WPA3 or something like that. When you look at enhanced security for 6 gigahertz, right? And this comes into kind of the design when you're looking from office spaces to stadiums to whatever or airports, right? Or cruise ships, right? And is understanding the complexity of this now. Now, majority of today's devices that you have today, your iPhones and Samsung phones, anything that's like that today that's probably made in the last a number of 5 years or so, is going to have at least some WPA3 compatibility in it. Mostly from a software upgrade, but at least you can use WPA3 on 5 gigahertz, which gets you ready. But if you've got a 6 gigahertz device, you're going to be ready with that. Now, I'm not going to go into the kind of the transitioning aspect of it today, because there's a whole other. We did a webinar on that, on transitioning. It's a little bit more of a. It takes a little bit of thought process, right? Because if you're going from 5 gigahertz to 6. Think of it in the old days of going from WPA to WPA2, right? That's we had a challenge there, and now we're running to that same thing with WPA3 and 6 gigahertz. So 6 offers us enhanced open, right? Got better authentication there, and of course OWE support, and of course WPA3, which gives us a better management of actually management frames are mandatory, but it also the encryption level is actually a lot stronger, because if you know WPA2 is breakable today, WP3 is less that. I'm sure probably about 10 years down the road, someone's going to have a supercomputer that is going to be able to break that at some point, right? But today, that is the most secure method of security for Wi-Fi. So even you can use Wi-Fi, you can still use you can use tongue twister there. You can use WPA3 today in 5 gigahertz, so as well. So that's something to keep in mind. Now, what about this Wi-Fi 7 stuff, right? Is this something that is, we got faster speeds needs and lower latency? Yes, we can. This is actually takes that 6 gigahertz to the next level. So there's not a lot of devices that are Wi-Fi 7 today. You don't have to rush out and buy them right now. Not a lot of the APs support it yet, but there is any of the mainstream APs like Cisco's, the 9100 and 9100 series of the 76 and 78 series are all Wi-Fi 7 compatible, right? So they're going to have all this goodness in here to understand MLO, multi-link operation, right? You got 4K QAM modulation, 320 megahertz, all the cool stuff that's in there. But that's that MLO that's actually going to, that we're going to talk about on another webinar a little bit later, where it goes into depth of, wouldn't it be cool if we could use the older legacy devices at 2.4 and at 5 gigahertz and at 6 and have them all talk on the same SSID, same security, so WPA3 obviously through all 3 bands, but being able to leverage all 3 radios. Now, this is going to be a special device that'll have to do that. If your device is Wi-Fi 7, it'll be able to handle all that today. Or if you're going to be supporting some legacy devices, but it's still a bit unclear about how that territory is going to run, of how you're able to add to use 3 frequencies at the same time. Still kind of the testing days, but I'll leave it at that for now, because for me, is that I come from the world of the radios, and I'm like, well, I guess you could do it, talk to 3 different radios at the same time, but it can be kind of a bit of a I guess varied mileage will vary, so to speak. Do a quick look on kind of the speeds and needs, speeds and feeds actually from a Wi-Fi 6 and 7. Of course, we have different spatial streams, and of course different maximum data rates as well. Now, if you're going to be doing those, plan to upgrade to 6 gigahertz, and the reason kind of like of talking about this a little bit, because it's kind of new, is that you all have to think about is, if we're doing 6, there's going to be some other complexities that you're going to have to worry about if you're upgrading those APs. So a lot of those APs you may have out there today, might be a lot of older ones, maybe they're out there from the field for about 10 years or so, and you've gotten your life out of them, and now you're going to upgrade. Make sure you take the cable, your cable plant into account. Make sure that your cable is ready, but also make sure that not only your cable plant is ready, but your switching environment is ready, because these APs are going to require a little bit more power as well. So looking at from your your management of policies and what you're going to be doing from a connection on the back end is going to be extremely important, especially when you're going beyond the gigabit realm, right? You're going to be on 2.5 or supporting 5 and 10 gigabit to an Ethernet. I know it sounds amazingly crazy, like, you know, I go back to the days when theoretical 1 gigabit was like, you can barely get to it, it's theoretical, and all of a sudden now we're surpassing it with 2.5, 5, and now 10, right? Multi-gig. Now, wait, there's more. So we get into kind of some of the cool things that we're doing from an Ekahau perspective is, you've got all of these cool things from a Wi-Fi perspective, but how can we make you guys IT superheroes, right? How can we take all that complexity that I talked about, how can we make it into a simplest form? Well, one of the things we can do is we can help you with kind of that effortless optimization, that high-performing Wi-Fi, and of course, stay ahead of those changes. And we can do that with our platform, whether we're going to go out there and survey that, grab some data with our Ekahau Sidekick 2, grab that data and help you enhance that network. Now, a little bit of a suite of our product, what it does look like. This is kind of just an overview of some of the things that we do here, from our pro software to our hardware and on our Connect subscription. But what's most important here is actually the data collector itself. So I kind of like to go into kind of uber geek mode, and I hope that most of you guys are here on that. And I wish I could see the chat or the raise the hand section here, but this is where it gets actually kind of fun, is because now we're looking at, what does it take to collect data such as this, right? I've got a Sidekick 2 here. We've got 9 customized wideband antennas that are inside the unit. We've got, which gives us unbeatable accuracy. We're backing that up with 4 independent radios. Those are enterprise grade, where we're looking at tri-band, so 2, 4, 5, and 6 simultaneously. And there's a built-in spec-ant, right, spectrum analyzer. Now, how cool is that to have all of that cool stuff in there to be able to collect that data to tell us exactly what's going on in the environment? And to get to that holy grail is something that we've been able to do. Now, we talked about workflow, and I know we were mentioning this kind of in the agenda, is how do we look at that workflow today of understanding how do we get from our surveyed environment, like of an existing or a greenfield, so brownfield, greenfield, and then maybe actually getting into a dashboard scenario, right? So we can do that through our next generation workflow, right, to awesome Wi-Fi. So we can, if we're going today and we have a site that has existing Wi-Fi and we're going to upgrade it, or maybe we need to find out what's going on with it just to kind of optimize it, we can do that with our Sidekick, and you can go walk with a mobile device. I can take that out there with an iPhone or iPad or Android device, walk the environment, understand what's going on, and then I can get a better feel for what the environment is, and I can then optimize it. And then if I need to go and change some channels, and that's all it is, or maybe I need to actually redesign it a little bit, I can do that through our AI Pro Online software. So we can kind of do that 3-step process if we need to. And we go into kind of in our next gen kind of predictive analysis. We're leveraging AI to its well, a next potential, right? Is how can I know that the data that I grabbed from that Sidekick 2, how can I use the AI algorithms from that data to place new APs on the map, or move the current ones without even drawing walls, without even doing any other augmentation? I can do that. All right, so let's get into kind of some demos here. So what I'm going to do is I'm going to pause for 2 seconds here, and then I'm going to go into demo mode and show you kind of what it looks like to look at from an accurate kind of, let's go into a kind of a design phase, right? Is what does that look like when we're designing? So we have a couple of tools here, and I'm going to show you one of them, if I can get this over on the correct screen for you, just so you can see it. There we go. And Levi, are there any questions in the queue there that you wanted to throw in?
No questions so far, Stu.
Okay, excellent. Okay. And oh, there it is. Perfect. Okay, now I got it. Now we're going to move this over here. One of the tool sets that we use here is obviously with AI Pro Online, and I'm going to show you kind of a cool thing here that I got set up here. Is from an AI Pro Online perspective, what we can do is I'm going to just, I've already just quickly selected my floor plan, but what we're doing is, if I can just move this out of the way here. Get this out of the way. Thank you. Perfect. Is that now what I'm going to do is I'm going to import a floor plan. So in this case, I'm going to start a little bit more of a greenfield here. I'm going to talk about greenfield, and I'm going to talk about kind of an existing design as well. So from a floor plan perspective, what's cool about this is that we can actually grab any type of PNG, JPEG, or even AutoCAD file. AutoCAD's I like because what I can do is I can assess the layers that are already embedded, right? So what I'm going to do now is I'm going to open up that CAD file. It's going to assign the layers here. And then once it assigns the layers, it's just going to tell me, hey, okay, now you have this many types of walls. This is the attenuation of it, and this is where they are. And then you can actually go ahead and then let that apply. So that's going to come up here in just a second. Of course, it might have, my password might have timed out on the time I've left it open, but we'll see what's happening here. Now we'll let that kick in. And I love it when the world of live demos works. Oh, there it is. Okay, I'm paying attention to the screen. Excellent. So here we go. All of the actual layers are in place here. So you're going to see all of the things that the architects use, right? So the architects are going to use all these hidden kind of cryptic walls, and if you've read enough of these over the years, you can pretty much understand most of them. But what we've done is that we're able to read them, and we've applied an algorithm to automatically just start assigning it. So we know what most of the stuff is. And so, which is the cool part, is I can go ahead and assign it. So I'll finish that, and it'll go ahead and place all those walls in for me. So now it's going to go ahead and load that CAD drawing into a plan. And what's cool about this is that we can actually go in and start designing it. And we can design with any access point we like, and we can choose from the the thousands of access points that we've got available to us. And then we can get designing. We can put in our requirements, what we have, how many devices that we're going to be using here. So we're going to show you that to you in just a second. Once this starts to draw out all the walls for us, and let's see if the magic happens just as fast as it should. And I'm in the dev environment tonight because I'm showing you something pretty cool after this. So production is a little bit faster. Excellent. So now it's going to ask me, hey, did you want to add some more floors? No, I'm going to finish it. But if I did, it would be able to stack the floors for us. So now what we're going to see here is I've got a floor plan here. It's all ready to go. I've got, and it already drew the walls in for me and drew all the columns, and drew all the necessary things that I needed. Now it comes to time is that, well, should we start placing some access points? Should we establish a requirements area? We should probably do that. So let's let it do a requirements area, and we'll probably put some exclusion zones in. Now before that, let's do the exclusion zones here. Well, I know I'm not going to worry about in this case here. I'm not going to worry about the walls. Sorry, not the elevators, I should say. Here we go. Let's get back down in here. And let's turn off the walls for a second. And I think I'll put this back in here. Area tool. Come in. Area. Maybe my mouse is not kicking in. Oh, there we go. Hang on. Da-da. Okay, there we go. And so what I'm going to do here is that I don't need any of this. So I'll put this in exclusion. Good. Oops, hang on. And put that back over there. And right click. Perfect. Okay. So I got this area, and I know that I don't need this area here. So I'll just put that in place. And this is going to be, and I'll tell you why this is important in a second, because, and is that I don't need these specific spaces. And the reason being is that that I don't need to worry about access points in these areas. So I can save some time and money on that, and I'm not having to worry about that. So I just quickly to draw that from my requirements area, I can automatically just place that area here. And I'm going to go ahead and do that. And it automatically did that in the drawing. Now, the next part here is I can actually go into the placement of the APs as well. So in this case here is I can go ahead and look at the placement of the access points. I'm going to now choose my Cisco access points. And I'm going to say, you know, I want to have the now, I want to put in the 9166 or the, hang on, let's put in the 9167. Oh, are they not in this one? Oh, this is in the dev version. Yeah, so it's not in hiding. That's fine. So put in the 9166s in here. I can place that. Actually, hang on. I think I know why it's not in there. There we go. And 9160. There we go. 9167 and 9168. No, they didn't actually put them in this one yet, but that's fine. That's not a problem. I'll just do this one here. That's fine. So I can go ahead and place those access points, but automatically you can see that the APs are being placed, right? And so from a placement perspective, I can let it plan, or I can actually go ahead and start planning it myself. So if I wanted to go ahead and start planning an AP, you can see that it already knows that the walls are there. And so then I'm going to go ahead and start planning access points for this particular map, right? And I'll just place some access points randomly in here, and I'll put them over here. And now you can see I've got a bunch of access points ready to go. So for that, I've now planned out for my 2.5 and my 6 gigahertz access points. And if I need to select these APs, I can see what the heat pattern is going to look like. So this is all from an online perspective. So we're using the AI intelligence to automatically do that for us. We can do it from an AI auto planner based on the requirements that we have and the height of the building, the floors. And then we can go into more of the environment. We can tell it, you know, in the areas, what does that area mean? Like what's in that area? Is it a high performance? Is it just a medium or best effort, or is it a custom profile? We can actually put that in there. And then we can tells us how many APs we're going to need and if we're going to meet the requirements, right? For signal dominance, or we're going to look at from a signal strength perspective. Maybe we want to look at SNR if we're going to meet those goals as well, right? We can do that.
Stu, real quick, we got a question.
Yeah.
How many dBm do you use for 6 gigahertz high density environments as default?
As a power level, well, a power level we can start off at 14, and then you can kind of lower down a little bit, right? 14 is a good medium to start at. If that I think that's where the question is going, because if you're looking at from an access point of what the power level should be, 14 is a good medium to start. You may end up having to bring it up a little bit or down, but 14 is a good baseline to start with. And that's for even that's 4 and 5 gigahertz as well.
Okay, great. Thank you. We've got one more
Okay.
from Charlie. Can you place a couple in spaces that the physical plant permits and then let the software work around that?
Oh, so you mean like let it, oh, I need an actual AP here, but let the rest of it design? So what you could do that. So what I would end up doing is if I wanted to say, okay, let's do an auto plan, and I will place the access points and I'll place the devices, and it'll go ahead and do that. Then I can say, well, yeah, let's do this again. Let's do it let's resolve it. And yeah, the dev environment should show it. Yeah, but it's what it is. If I want to go ahead and say, let's place a tool, I need an access point right in here in this room, right? I can place this AP first and then let the AI design the rest of it if I wanted to. So the answer is yes, I can. So if I want to do that, actually, let's do it together. That's no problem. So let's do that. And I'll get rid of those. And I'll put and let's make sure we show it one. I'll put the access point in this room and down in right here. I'll put an AP here. And then if I want to add in the rest of those APs or do the assisted planning, I can now leave that AP there. And then these ones will actually pop up around it. And it's calculating its positions based on this first one here. And I'll let that kick in. I should probably use production tonight. Dev environments usually is less performing, but there was a couple of things I wanted to show you in here before I switch over to the production. Let's let it worry about it. No, is it going to kick in? It'll kick in. But the answer is yes, it does do it. If I wanted to do that. And I'll let it finish. But what I did want to show you was, and I'll show you here once I place some access points in here, and I'll just do this here. I'll go back. There we go. I wanted to show you this piece here is kind of where we're going on the next phase of this, right? Is that how can I look at this from a kind of a three-dimensional floor plan piece, and then showing kind of the walls aspect, right? So in here, what this is giving us is our next kind of release is that thinking that, well, now that it's cool that we can actually see the three-dimensional view of this, but we also want to know is like, how can I do that kind of kind of the Minecraft walk, right? Or I guess you can all say Castle Wolfenstein walk, right? Probably some of us remember. Yes, you can kind of do that walk through here. The next part of it is how can we actually see how the actual RF actually broadcasts from the top down. And that's our next phase of showing you next is that what does it look like from the top? We can see how it looks like on the map, but wouldn't it be cool to see it the way it's coming from the access point itself? And then how it's actually projecting down along here rather than seeing on the floor. So those are some things that we're working on our next piece of that. But this gives us a good idea of how this office environment, and this does exist. I've been here, and this is actually one of our offices, but we've actually let the AI actually design this office, believe it or not. And it actually works just fine. So the AI designed the APs that actually put them in place and based on all the materials and whatnot and the exclusion areas, and we got ourselves a good design, and it looks pretty much close to this. I've placed it on here, but I do know that the AI designed it in pretty much close to this. Now, that is from a perspective of the AI online design. The next part of it is I wanted to show you a little bit. Next part is how do we look at data from the cloud? Let's say if we have an actual environment. So one of the things that we can do, as I'm going to show you here, is what does it look like? We'll get you in the next screen here, and I think we're doing okay for time here. We'll go to this one here and show you that one. Da-da. There. Oh, good. I actually have it right here. Perfect. Okay. So let's get another screen in here. This is actually another environment where we looked at from a design perspective. But this actually piece here is what is it from an actual survey, right? How does it look like? What does the data look like from a survey perspective? Well, I can look at that from kind of the APs themselves and how they were detected. I've got some Cisco Meraki access points here based on a survey, and I can see exactly what those access points are doing. So I know we have APs on channel 11 and 6 and 48. Obviously, we have some things that we need to fix in there from a radio perspective, but that's okay. But the point of this demo here is to show you that what if we were to increase coverage in certain areas, or we were to move an access point? What would that look like? Now, in the old days, what we would have to do is that we would have to we'll do a survey and then we'll do a redesign and place new APs in those same areas. Well, you don't have to do that now. So this is all survey data. I can actually now move this access point right now, and I can say, I need it in this room. And so now we automatically know what the actual environment's going to do here. So I push it over here, and I can push it over there. And the effect is now showing that because we already calculated the walls based on the survey from the Sidekick 2, it automatically knows, wait, how that AP is going to behave. And I don't even need to physically move it. Now, this is a super cool feature, and it's a super time saving, in my opinion, because if you think about all the times when you have to go out and troubleshoot, or you're looking to redesign access points, well, what if we just move it over here? Is that, will that fix the problem? Or in this case here, this customer is going to be upgrading access points. So let's go take a look, and let's say, you know what? Why don't we redesign this by replacing these access points? So what we can do is, as you can see, it's automatically placing them on here already. But what if we were to select all of these access points and say, here's all the APs. And now what I want you to do is I want you to change these APs. And I'm going to tell you to replace these models with a 9166. And now I'm going to show you what the 9166 looks like. I can even change I can change the radio power as well, but I haven't added any new access points. All I've done is I've actually replaced them. I'm using the AI algorithm that's already built in. The Sidekick 2 data is telling me exactly how that AP is going to perform. So I'll already know, without a doubt, how a new access point in these locations is going to fare, and whether or not I need to actually move or augment them. Now, this is a cool way of gathering that empirical data from the Sidekick 2 and putting it into this into this kind of realm here to show us what is the possibilities of this before I even actually go on site to put anything in the ceiling or change it. Maybe I want to change to a different model. Maybe I don't need the 66. Maybe I want to go to the 67. Maybe I want to go to a lower model, or maybe I want to change manufacturers. I want to give another manufacturer a try. You'll be able to see the difference of the heat patterns each of those antennas, because no two access points are alike, right? They're different. Their radio plans are very different. Their properties are very different, especially from an antenna point of view, right? So when we look at what their antenna might actually look like here, let's say from a 5 gigahertz perspective, I'll be able to see, if it pops out here, I'll be able to see exactly what I'm going to be dealing with from an antenna perspective. Okay. Now, that's just covering from how do we do a redesign and how we take that. Now, your next question is, well, how do I get all this stuff into the cloud that I gathered? Well, one of the cool things is that, I think I missed that question there. Hang on. If you miss wait a second here. Let me grab that. Okay, if you run the Sidekick after the installation, can you compare with the planned covered? Yes, absolutely. So that's what we call a validation survey. So you can actually go implement the design, and then you can go and survey that. Now, it just so happens, I actually have something here I can show you. And you'll be able to see that. So let's put that on the big screen here for you to see, and put that over there. And let's let me get that on the screen here. And are you guys seeing it yet? Hang on. Perfect. Okay, and I'm going to broadcast it one more time. Okay. Can you guys see the iPad now? Is that working? Yes, no?
Yes, we can, Stu.
Perfect. Okay. So this is actually a validation survey. You're seeing the iPad here. And from a validation survey, I've used a Sidekick to go ahead and actually do the survey. I've captured all the cool data from a technical aspect. I know from without a doubt what the access points were doing at any given point of that survey. So I'll know exactly what it was broadcasting, the SSIDs. And in this case here, I found some hidden SSIDs. And of course, that was the Meraki meshing SSID that was broadcasting. And that's what led me to believe, we need to disable that. We need to fix that. And you're saying, well, why did you need to do that, Stu? I said, well, because if you look down closely there, you'll see that it says 6, 9, and 12 data rates. Well, I'm not broadcasting 6, 9, and 12, but the mesh is. And so that's taking up some space in that environment as well. So that's something you want to eliminate completely off of your access point. So if you don't need the mesh, just get rid of it, because it's not, if you already have a network set up, you don't need the mesh. So it's a feature that you can turn off in your network general settings on the dashboard. And that can be extremely helpful for fixing the performance of your network as well. So finding these things, the Sidekick finds is a huge time saver. So now, looking at the kind of the data aspect, I can see not only from the access point, but I can look at the combined waterfall, because I may end up having to find if there's drops in the performance. Maybe I've got some dropouts, and maybe there's going to be some red showing on the bottom here that'll say, yeah, you dropped out, but you actually are okay. Your pings are all good. You're roaming just fine. Right? I'm even going to be able to find things from the validation survey as what is the heat pattern of that access point, right? What does it look like? Is it doing the right thing? And you're looking like, wow, how is it not working in that room, right? Well, it just so happens that in this room, there's actually some columns that you don't see that are there that are actually creating a shadow effect where that access point broadcasting that room is not good. So hence an AP was put in there. And the AI put that AP in there, believe it or not, which was really cool. And you can see that, which is nice about when you do a validation survey, document, document, document. And I know that's one thing that we all forget about doing is documenting our network, because we love documentation, right? Everybody loves documentation. Document your network and always take pictures. And you can see I've got a picture of the access point here, right? That I can go and see. And then I've got another one. I've got a close up of it, so I've got that ready to go, and I've got some documentation there. And the same, if I'm going to find something that shouldn't be there, like, oh, what's this, right? This is the latest kind of little interference little guys here. These actually are from Lutron, and they actually control lighting. And so what they do is they have a wireless sensor that goes back to a pad, and you can control the lighting from there. Well, it's a great thing. But what nobody told anybody is that they didn't really fall into the right planning of wireless. They're on channel 2 in 2.4, and they created SSIDs for each individual. Well, this is more of just like, okay, we need to kind of fix this up. But the good thing is that we're not using 2.4 in this environment. We're using 5 and 6 only, so that's okay. But it was nice to know that there were things in the environment that could cause something later down the road if we needed to open up 2.4 for something. And of course, you're going to find your other folks broadcasting in here, and using colors and labeling things along when you're surveying is extremely important, because this allows you to be able to kind of figure out just to classify things that you need to go look at later. Maybe like this, I had a printer actually over here that'll show up later on another survey. So this validation was great, but then I had another survey that would show a little bit later that would show the validation of the access points being in had a printer that showed up. And that printer was actually showing up and causing a bit of a disturbance, right? And you say, okay, well, let's go see what that one was doing, right? And I will go back to this one here, and we'll open that up in a second. Oh, I don't need to synchronize that one. Let's go into that one. Perfect. Open it up. Perfect. And now you can see I've marked another AP here on another survey as I had a LaserJet printer. So these are things that prop up afterwards. So you think you may have seen it now, and then the dashboard shows that there's something else, and like, well, where's that? So then now you can go and track it down, right? And then that's when you can open up the analyzer software and go in and find go into a deeper dive of that as well. So those are some of the things that you can do from a survey perspective. And yes, you can survey in buildings, parks with GPS. You can do all that cool fun stuff as well. All right. Now, just to kind of get back on track here from a perspective here, I know, so from a timing perspective, and let's make sure I got my window here, the right window. There we go. And oh, excellent. Let's put that up. Here we go. Okay, so some of the things that here we go. So some of the things that some of the access points, obviously, that we can actually design for. Obviously, there's over 5,000 different types of access points. Here's to name a few that are in there already. Of course, we can design for different antennas and whatnot as well, and we can help you with that. All right, now talking about from a provisioning a dashboard perspective. So when we do from a dashboard perspective, one of the things that we want to do is we want to make sure that if we're going into doing a kind of a dashboard perspective, what we want to do is we want to understand how do I make this thing easy, right? Well, one of the things we're going to do is we're going to get our floor plan. We're going to go out and do a survey with our sidekick and grab the data, right? Well, automatically when I grab that data, one of the things that's going to happen here is that I'm going to go out for a walk and I'm going to understand where my APs are planted. So in that case there, we had some Meraki access points already placed on the map. And well, we didn't have that map inside the dashboard at all. So the cool thing we can do is, well, we're going to go do a survey. We've created our documentation. We know where the access points are. We've added some pictures to that as well. And now we're going to take that over to the dashboard. So one of the things that we can do is that we can now take our project file that we've already saved on our dashboard in the Ekahau dashboard in the cloud, which is Insights, and then we can actually provision it through two different places. So we can actually do it through DNA Center, or the old DNA Center, of course, Catalyst Center as well, and the Meraki dashboard. Now, from a Meraki dashboard perspective, what is actually cool is that you can do this through the API key. And once you've done that through the API key, you're going to choose your region. You're going to go ahead, and then it's going to ask you about the floors that you want to import. So if your project file has more than one floor, you can let that go through. Now, once it does this, it's going to synchronize the data that you collected on the survey. It's going to know the MAC addresses of those APs, and it's going to synchronize it with the cloud. So now you can see that they're provisioning the map here, but in the background, once this happens, now there's going to be a two-way sync. So now we've sent off the data to the Meraki cloud, and so that's already been placed, and then we're going to get back the serial numbers and the names of those APs. So if we didn't know the names of those access points ahead of time, well, we're going to know them now, and they're going to be synchronized to the dashboard, our dashboard as well. So we'll, in our project file, we'll have that synchronized. Now, if you wanted to try something out like this, you wanted to kind of try to see what it looks like on your side, there is actually a Cisco dCloud demo, and I think most of you guys are probably familiar with dCloud as I am, but this is a great place to kind of go and do some lab ups of script environments, and Ekahau is now inside Ekahau dCloud for you to check out. And of course, I talked about the 3D viewing perspective as well, which is coming soon. But the other perspective that I was going to talk about here was one of the things is, before I get to that, is there's one more, and if I get my screen up here, is we're going to talk about kind of a couple of different ways we can do from a survey perspective, right? So from a survey perspective, one of the cool things we can do is, you talk about surveying, is that we can actually do kind of a just go survey. So this requires you that if you want to do a survey where you don't have an actual floor plan, you can actually use the LiDAR that's actually built in to your phone, and you can actually go ahead and create those actual floor plans. So you're saying, okay, well, that's kind of cool, Stu. How the heck does that work? Well, of course, I've got a demo to show you right now how that works. As you can actually see, is that we're going to go ahead, and our next, if I can click here, we're going to actually open up the phone with the survey app, and we're going to get started, and it's going to start capturing the walls. And what it does is, as you walk around, it's going to start drawing on the floor plan. Now, what's really cool here is, now that floor plan is being drawn out, you're starting to take shape. Now, it doesn't collect people or places or things; just collects the walls and the solid surfaces. Once it goes through all those solid surfaces, it creates that floor plan, and it's collecting the access points locations and it's also collecting its channels and all the spec and behind it. And then you're left with kind of a sketch of the generated as Just Go. So that's what it would look like as a Just Go. This is actually our first gen. Our second gen goes beyond this, which is coming in January. But this is actually, instead of me not worrying about finding the floor plan quickly, but I have to resolve an issue, I'm just going to go out and survey it quickly. I don't really need a floor plan because I already have it in place, but I need to quickly resolve an issue of what's happening. This is where you can use the Just Go to do that. Yeah. And then from an autopilot to Just Go, this is kind of a kind of a side-by-side. An autopilot is something we released a couple years ago as well, where we're using the AR kit portion of the Apple iPhones to be able to understand like how we can walk around without clicking all the time, doing that we used to do. So there's kind of a side-by-side of where the access points were placed. So the Just Go is a very viable solution for doing capturing some data on the fly. All right. Now, one thing that I do have that I will show you here quickly is, before I get into that, is one of the cool things that we are working on from an analytical point of view, and I'll bring this up here so you guys can see it. And it's actually kind of fun, is this is actually our speed test that's now integrated into our analyzer product. So if you're looking at from a survey perspective, you've gone out, you've surveyed something, now you need to figure out what the heck is going on from a perspective of, tracking something down, or maybe I need to look at the spec and. But one of the other things you could do is actually run a speed test. And so with a speed test app that's integrated now, we can actually go and do that. So we can actually test from a data perspective. We're going to be testing a video as well. And you can see that live on the spec and. So here you can see me. This is actually a test I ran here at home on my 6 gigahertz access points, my 9166s. From Cisco, and then I can a shameless plug, but I can actually show you the speed here that I'm getting here from the fiber internet that I have here at the house. Now this is actually pretty cool. I was actually quite impressed with it. This is my as soon as I turned on the 6 gigahertz and had some fun here, and notice that I'm doing it about 160 wide. So I'm pushing as much as I can out of my internet pipe there. So that is a new tool set that we've enabled with in the Ookla realm of analyzer. So you're going to be seeing the speed test, and also we're going to be looking at a couple cool things like down detector as well, integration that you're going to see coming shortly. And yes, we do the packet capture as well. So that is also another cool feature. So if you're a PCAP fans, that's another cool feature that we have embedded as well. All right. Now, I kind of wanted to follow up if there's any kind of questions and whatnot, and I think we're approaching the top of the hour, aren't we not there, Jason? I think.
We are. If you've got more to go through, we can definitely go through more. We can go to 8:30. I think that's our normal stopping time. But if this is where you would normally stop, you're welcome to.
Well, yeah, no, I don't want to bore anybody, right? I like to kind of have some fun with it, but
we're having really good back and forth in the chat. Levi's really been on top of it. So
excellent.
No, I think you're doing great. And if you have more to show or demo, please feel free.
Actually, you know what I do? I actually have some kind of captures here that you guys might actually find some fun. How many out there are kind of love to look at interference? I'm sure there's a bunch of you out there that would love to kind of see what interference. Well, one of the things that I had here is we'll just spend a couple minutes on this is while I was at an event with my colleagues not too long ago, and we were looking for some kind of some interference, and I had to kind of capture this. And so what you're going to see here is and I'll let it play, is you're seeing a spec and capture here using our Sidekick 2 and AI Pro, which is our design software, but it's showing you where we had the issue in 2.4 gigahertz. And you can see that it's running fine and it looks like it's going pretty good. But what's happening is that if you look closely now, is we're going to start to see some kind of strange effects happening really quickly here. And I might have to speed up here it is. Now we got a continuous transfer happening. And now you're going to start to see it kind of cut through. So what's happening is that clients are now disassociating from 2.4. And they're getting it to a point where the interference is actually slicing almost like fingers on a chalkboard. And if you can see it down in the bottom here, it's actually happening there. You can see the fingers there. And I'll speed this up just a little bit along here. But as we get along, go through this on 2.4, you can see that with all of this cutting across all the way through, through the entire 2.4 band, it's actually kind of hurting the clients, and they're not associating whatsoever. Now, we did track down this device, and it was actually called a it was a term of photonic energy. Now I'm waiting for all the Star Trek references to come out in about 2 seconds here in the chat. But yes, it was a photonic scanner and what it did the claim was by the vendor is that it encapsulates a kind of a warp bubble around the AP and the client to enable it that it would be completely encrypted, the transmission. Now, I sense that this is more of like a space age technology, but when I saw this, I'm like, oh my, that can't be true, right? But the way that it was doing it. Now, when these guys actually saw this, how it was cutting through, it was kind of like, oh, maybe we have to go look at a filter on that. So yeah, you might have to look at that. But it was cool because that customer ended up going back and grabbing one of our devices because they figured out, hey, you know what, we better start testing this a little bit more. But their device was actually kind of cool what they were trying to do. But it was the name that caught me right away, and another a fellow from Aruba who we both tracked down, and we looked at each other like, what, a photonic scanner? Like, really? Like, it was very much yes, I know, someone fired up a tricorder. You bet they did. Right, that's exactly what it was. And so these are kind of the cool things you end up kind of uncovering out in the field, and it's a lot of fun to find that. I do have a 6 gigahertz interference one, but I'm not sure where that's hiding at the moment. I usually have it right on the screen here, but 6 gigahertz is something that you will definitely start to see very shortly now, and I have seen it actually at where have I seen it? At a NASCAR race, believe it or not. So 6 gigahertz will actually show up in that realm and giving you kind of the it's cutting through as well. And let me see if I might even have no, I don't have that handy off the top of my head to show you. But if you were to kind of go and look at that and find it, you would definitely be able to see that. But I can show you one piece of interference, which was actually really cool, was that this new office that we were building here, it actually had a transmitter detected within this realm. And when I get into kind of understanding why empirical data matters, is that I like to kind of go back and look at from the interference section, right? So from an interference, I want to know what the footprint is of these and what the zone of impact is. So when I take that sidekick out and I know that there's a zone of impact on this particular area, this is something that it cause for concern. Now, there's a minimal zone of impact on there, but this is actually, I could trace this coming from across the street from another building. And this particular area here from an interference perspective is, I'll just go back here and look at it from the spec-an here. As I can actually see, while I'm going through here, I will definitely be able to find out where the strongest part of that spec-an is. And so then I can actually go ahead and let's break it out into a new window so we can see this and have some fun here. We can actually break it out and look a little bit deeper if we needed to find out if it's really something that's bothering us or not. Now, in this case, it was a little bit bothering us because I was getting variable ping times, right? So this was, was it 2.4 issue? Was I connected to 2.4? Actually, yes, I was. Strangely enough, when I did this particular survey. So I was like, okay, I wanted to see what's going on here. Now, I didn't get kicked off as much as I could visually see, but it was something that in this area caused for me a little bit of disturbance. But it was good to know that there was something here, because in the past, in our corporate offices, we found 5 gigahertz interference continuous transmitters coming from the most unlikeliest places like compressors or old refrigerators that would be causing an issue there. All right. Now, from a tricorder perspective, I think what I can do here is I can engage my. Oh, did I unplug the wrong one? Yes, I did. I unplugged the wrong input there. No problem. is I will throw on my sidekick temporarily here, just so you guys can see that. And then I'll show you kind of what a live environment is, what you're going to be looking at from this. And then we can end off there if there isn't any other questions. And I'll show you a couple of two things we're working on, kind of some somewhat some top secret stuff that we're working on, but I think you guys will I'm okay to share it. So let's have some fun here. So we're going to show you two things here. I'm just going to plug my sidekick back in and make sure that my my audio is working the way it should be here. Perfect. My audio might have kicked out off of there. That's fine. Okay. So now what we're looking at, this is actually live. So what you're seeing here is actually what's in my actual place here. So you've got a bunch of different SSIDs here, right? So I can look at just only mine or everybody else's. So if I wanted to look at Ecto 6, right? I can see that I got 6 gigahertz running and channels 5 and 69, and that's running just humming along just fine there. And I can see 5 gigahertz. It's a little bit busy. These are mostly probably the kids that are running stuff at the moment. That's probably what's happening in here. And I've got like one of my older access points out in the on the field, see an old Wi-Fi 5. So that's actually important. If you're looking at access points, we'll be able to show you the tech version of it. This helps you in identifying access points in the field that are older, and you may have overlooked it, because when you get into hundreds and hundreds of them when you're doing surveys, you kind of just you tend to kind of like, oh yeah, I don't know where that is, right? And the great thing is that we map them out for you, like from on the map. So we'll be able to tell you exactly where they are on the map as well. So this is actually kind of a live perspective, what we can see from 2, 4, 5, and 6. And I like to actually kind of watch in here. I'm kind of a newer geek when it comes to kind of looking at these kind of cool things. I can go down to the one second time intervals, and you can actually see how it's actually how it's separated in between, right? It's how Wi-Fi is actually working. So whether the device is transmitting back and forth to the access point, you can see that there, and you can see some looks like some data pushing out pretty good right there right now. As it gets red or gets a solid, you can see how that's kicking out. No interference here tonight, but I do live close to a border where I do get lots of interference from 5 gigahertz quite a bit, and it's usually in this realm. Look at that right here. Looks like we are going to see something kind of fun. Look at that. So if you look at this guy right here in channel 1, there's a bit of a finger right there, and that is going to be a most likely a wireless camera. It's close by, but not enough for me to trigger what the interference is yet, but I can see it. It's right there. And that's a cool thing, because for me, I'd be like, okay, how do we let's get closer to that. So if I can get the sidekick closer to that, I can track down what that is. And those type of things can actually be a little bit of a pain in the butt, especially when something that's in your realm and you're on channel 1. And if the intensity is high enough in the duty cycle, that's when it can cause some issues there for you. So we found something, a little gremlin, right? That's hiding in there. So we got to go. We got to grab the proton pack and go find it, and then or I should say the sidekick 2, and go and track down that little guy. All right. So I'm going to leave you with that, and I'm going to move this screen. I'm going to just pause there for a second so I can bring up the other screen. And where's my other screen here? Back, and just waiting for my other screen to. Where did it go? Where did it go? There we go. Okay. Here's one last thing that I can leave you with, is one of the cool things that we're doing from a design perspective is actually inclined surfaces and extended modeling capabilities. What's really cool about this is actually that we're looking into doing more from a stadium perspective. This is something that I love as well, and supporting BIM files, which is actually looking at 3-dimensional spaces, which is now a lot of architects use now. So putting on your 3D goggles and kind of walking through the space, a lot of architects do this. But from us, what we're going to do is we're going to take those BIM files to the next level and actually create that 3-dimensional space. then we can actually give you a much more clear indication of how that Wi-Fi is actually propagating, so that we can design it a heck of a lot better. So inclined surfaces has always been the kind of the holy grail to make sure that you can actually do that. And this is something that we've been able to achieve. This particular feature is coming definitely in the first quarter of next year. So stay tuned for that. This is kind of the cool feature that we're doing. I can't wait to use this, especially when it comes into working on larger buildings and in cruise ships. This is actually going to be super cool. And in fact, we're going to be working with a customer on that to kind of test that out as well. So this is a really a fun time to be kind of in the wireless realm doing this stuff. Now, from just to end off is let's get back on my slides here. Is we do have kind of a for those customers that are our Ekahau customers as well, we do have an Ekahau public channel on Slack. Slack is another medium for doing kind of chatting amongst folks, and I guess you can call it the new MIRC or the old IRC32 of the old days. I think I'm dating myself, but this is from Slack. We do have a group here. If you want to go there, you can actually request access, and you guys can join in and ask questions about Wi-Fi. If you're starting to learn things about, or you're using our products and whatnot, we have all of our product teams on there, so you can actually ask them some cool questions. So it's a really good resource as well. So, all right. Excellent. So it looks like that's good. Oh, closed captioning was on. Hey, that's even cooler. Now I can remember what I said. All right. So did we have I think we did well in the chat section. We have any Q&A stuff in there, but I think it looks like we got everything from the chat. But I'm open to any questions, folks. If you want to ask something a little bit more, or maybe yeah, go ahead and ask. It's something I didn't cover. You kind of want to see some of the couple of things we do in Wi-Fi. Shout it out if you like. Well, we got a couple more minutes.
Yeah, we did try to stay on top of it in the chat, and I think we did a pretty good job here.
Excellent. Well, that's good. It looks like Rob's already a customer there in the chat. That's great. Thank you, Rob. Looks like he had to drop it, but yeah, love doing this here. So loved having some fun here tonight. It is 8:13 my time actually. Yeah, well, I'm in the West Coast like you guys, but usually I'm very accustomed to doing webinars in multiple time zones. I think I've counted 10 time zones I can do at once in one webinar I've done. So yes. What's the channel size you have to be using for offices for 6 gigahertz in US or EMEA? Great question, Alex. So with 6 gigahertz, you can use 2040 or 160. I would say that you're going to be best at, 80. So I said 2, 4, or 8. You can get away with 80. But it all depends on how many APs you have and a specific density that you can handle it. So if you've got enough space for it, yes, you should be able to handle 80 in a small office environment. That's not going to be a problem. 40 you can run just fine. Yeah, for sure. You're going to have a lot more space in there. And remember, it's all about efficiency too, right? So if you have the bandwidth to support it, that's the one thing that you want to keep an eye on is, do I have the back end bandwidth to support that data? Because yeah, you can have all the fast speeds on that are the connect the fire rate, but are you actually pushing the data in the back end, right? So that's one thing to kind of like, oh well, I need to have that. But the answer is yes, you can use on a 5 gigahertz. I would stick with 20 or 40. 40 if you can. If you don't have a lot of 5 gigahertz neighbors or incumbents around you, you can get away with 40. But if you start to have lots of neighbors around you, then you might have to move to 20. But the 6 gigahertz, yeah, I'm using 160 because I'm having fun with it at home. But from an office environment, I would go down to about 80 to try that out. And then you can go to 40 from there. But 80, you should be fine, especially in a US environment. And in EMEA is a little different. So Europe has, so the UK has different channel ranges. Some parts of Europe has a little bit different. Middle East is a little different. Like Saudi Arabia is fully open. And same with UAE. And then get into other countries, there's a little bit more open on the channel size.
Okay, thank you. Any other questions? Anyone?
That is also something that is in the works, Jackie. So Jackie's question is, will the AI design give you a optimal positioning and direction of directional antennas if you design with external antennas? So we can design with external antennas, no problem. But what we can't do is we can't let the AI do it yet. So there's a reason for that, because we would have to put in markers of here's where I can put it. And then does that, like, these are the optimal places to design it, because you have to think directional antennas are very specific locations, right? They have to go here, and we're going to have to try to make it work. Now, from an AI perspective, you could start planning APs and then work from directional that way. But I think we're still a little bit far out from doing directional on like patch antenna types on an AI perspective. But we're not far away from it yet. But there's a little bit more complexity in the physics of that yet. And that's just like taking a patch antenna like this, right? We know they can go in different axes or angles, right? Or pivots points. So it's really hard for you to we can model this in AI Pro, not a problem. We can do that. But telling the AI that, well, I need one here. Well, then you have to say, well, what do you want to cover? So that will happen when we get into doing those more three-dimensional designs later. Then when we support the different file structures, then we can start to do this and adding that in there.
We did have a question come up in the Q&A. Is there a plan to have Ekahau auto-adjust power levels based on density? For example, adding more APs would start to reduce power levels in problematic / overlapping areas.
Absolutely. So today what we can do is we can run an optimizer in your current plan. So if you have a survey, you go out and grab the data with your sidekick, grab that data. We can have an optimization piece that'll actually do that for us. And from an optimization, what it does is I have that, so you can see that now. And where's my optimization? Here we go. I'll show you what that looks like quickly, just so you can see it. And where's my, I'll just share quickly here, share screen 2. Excellent. So you'll see it here is actually from an optimization perspective. I have one of the survey files here. It says I need to improve coverage, right? And it says I need to improve coverage on 6 years. Well, because I hadn't turned it on yet at this point. But in here, it shows me I got great coverage. But maybe I need to, what's in my zoom here? I may need to actually do it a little different. I may need to look at secondary coverage, right? Or channel interference. And from a channel interference, I need to know exactly what I need to do from a channel interference, what channels to fix, maybe some SNR records or rogue APs channel width as well, right? So all of these cool things that we can do in here, and to stop that, we can actually go ahead and create an action plan. And the system will actually tell us, by the way, this is the access point here. I need you to change this to channel, I need you to change it to 20 megahertz. And I also need you to change to 36, but also change the power level to 12, and so on. So it does create all of this and tells you how to do it. The next step of this is it actually creates and generates a report. We can look at network configurations as well. But when we look at the actual report itself, and as it downloads, and we'll open this up here quickly, is it actually automatically tells you what you need to do. And it tells you why you're doing it. And the reason why we wrote it this way was because we wanted to write it for those folks that are using good old change management, right? ServiceNow. You need to log a change, and you're going to do all these cool things because you might be resetting radios. Here's a documented piece for you, so you don't have to sit there and write it out. Because ask me how I know, because I used to have to write all this stuff out manually, and I didn't like doing that. I said, now we've got an automated process to help us. Now, which is cool in here is it tells us all these things, but it also can give us security reports and whatnot. But just imagine is that you have this data, and one of the things that we're doing with, let's go back to that screen here, optimizer, is the next part of this is actually deploying to network. So it's great out at the currently right now, but what it will do is that we can actually once Meraki or Cisco turns this function back on, what we can do is actually hit the deploy to network button, and it'll actually say, okay, what do you, out of all of the things that we recommended, what do you want to change? And then you get to check off the checkbox, and then it will automatically do that for you. So that's another integration from a dashboard perspective, how that we can actually help us kind of get to resolution faster. All right. Oh, do we have one? Is there a plan to have Ekahau auto adjust the power? Okay, we did that already. Yeah. Excellent. I see this is a different product than Ekahau AI Pro, which I don't think that has this feature. So yes, this is part of Ekahau Connect. So the Connect feature automatically has that built in. So when you're doing a survey with any of the tools that we're using that are part of Ekahau AI Pro, this is all built in. So even AI Pro has that button in there to actually send it off to the optimization wizard to tell you what you need to do. So this is all part of your subscription that you would have access to today. Yeah. Excellent. All right, Jason, that was pretty good. I think, and thank you, Levi, for joining us in your hour. You're a little bit in a different time zone than me, than us.
Only an hour.
Only an hour. Okay, only an hour. I thought it was 2, so we're okay. Excellent.
Need help? Call our cybersecurity team and book a consultation with us today.